Hello, meteorology students. Welcome back. Today, in this very first lecture here of week one, we're going to actually be going over the atmosphere. We're primarily going to go over two things. One thing being the composition of the atmosphere and also what the early atmosphere looked like. We'll go into that in just a little bit. I think there's only one slide. So, majorly, we'll be going over the composition of the Earth's atmosphere. So, let's get started. There we go. This is from my live class. Okay. So, the first thing about the Earth's atmosphere is that it's very thin compared to the radius of the Earth. So, as you can see here, the radius of the Earth is just over 6,000 kilometers. But actually, right here, like from right there to just right there, is going to be where our atmosphere, actually is. If you can see down here, if the Earth was the size of a beach ball, the atmosphere would be thinner than a piece of paper. So if that helps you with size comparison, our atmosphere is very, very thin actually compared to the Earth as a whole, which is kind of cool because, all of us live here down at the bottom. So, it really determines how we live and where we live and what we eat, different things like that. So, here's another picture. Basically, you can see what that atmosphere kind of looks like if you don't have the earth kind of distracting your eye. You can see how the density or the most of the atmosphere is actually down here closer to the planet where it kind of tapers off into outer space. We'll go over this in a little bit here, but it's definitely more dense down here at the surface than it is further up, and there really is no like definitive end to our atmosphere. So that's why you're kind of seeing this like gradual just kind of like end of it, kind of cool. Okay, so what is our atmosphere actually made of? Primarily our atmosphere is made of nitrogen. You can see this is a graph here. 78% of our atmosphere is actually made from nitrogen. It's not oxygen, like I think a lot of people think. But oxygen is the next, gas that we'll find there, and that's only at 20%. So, we have the nitrogen at 78%, oxygen at 20%, and everything else is just going to be pretty much a fraction of a percentage you can see here. The next one being argon, almost a 1%, but not quite. And then everything else is just super, super small amounts of it. Xenon is here, like very, very small, small amounts. These are permanent gases. They're always there. They're not going to go away. But we do have variable gases as well. Now, what that means is that these gases kind of like come and go. They're not at a constant rate. They might change depending on where you live and what temperature it is and different factors that determine that. So our number one variable gas is going to be water vapor, and then our second one is going to be carbon dioxide. Okay, so those of you that are a little familiar with climate change and climatology in any way, those are both greenhouse gases and they're both variable, right? So we're adding more to it, and that's, what part of you, if you guys have heard of it, what part of what's causing the warming that's going on our planet. That is, though, at the end of the class. At the end of the semester, we'll go over climate change. Don't worry about it if you don't know. And you can see ozone. There's a little bit of ozone down here, and that is variable as well. Okay. Now, water vapor, like we just said, it was the number one trace gas, but it's also the most important trace gas. Okay, the amount of water vapor in the atmosphere is going to be determined by a few different things. One being temperature. So you're going to have more water vapor around the equator, like where it's warmer, than we will at the poles. At the poles, there's very little water vapor in our air. So that's where it's variable. You're going to have it like you're going to find it different places and also different times. If you're in the Midwest and it's winter, then you're going to have less water vapor in the air than it is during the summer, even though, you're located in the same place. So it can be seasonally variable as well. Let's see. It is invisible, okay? So water vapor is not the cloud, itself. It's going, that's once it forms little droplets, okay? Once the water vapor condenses from the gas into the liquid, then you're going to see it as a cloud. But it's going to be invisible. Like I'm breathing it right now. You're breathing it right now. I'm sure my dog is breathing it right now. Just keep in mind, it's not going to be necessarily the clouds. It's going to be there and we're not going to be able to see it. Okay, and then over to the ozone concept here. We saw that down the line of things of being variable gases in the atmosphere. Ozone, or O3, okay, so it's going to be 3 molecules of oxygen. That's what makes ozone. Near the surface is going to be the primary ingredient of smog. Okay, at the surface, it's bad because it's bad for us. Okay, but 97% of the ozone actually is higher up in the atmosphere, in a layer called the stratosphere. We'll go over the layers of the atmosphere here. I think it's like one video from here. But 97% of it's going to be higher up in a layer called the stratosphere. That's the ozone layer, and that is good, okay, because it protects us from all of the UV rays. It actually will absorb it, and so we don't have to worry about it coming down to us, and that's a good thing because those UV rays would not be good for us. So one thing that actually does I would say deplete the ozone layer, or the ozone, is going to be CFCs. And these are chlorofluorocarbons. I have a hard time saying that. Okay, so that's going to be the thing that created the ozone hole over Antarctica, okay, during the Montreal Protocol in the late 1980s. This is what helped ozone layer recover because they kind of put regulations on CFCs so they're not as much put in the atmosphere anymore. When I think of CFCs and when I think of the ozone hole, when I was younger, way younger, I used to put a lot of hairspray in my hair with this product called Aquanet. In the 80s, they had these huge hair that went over you. That actually, the spray, the hairspray, the Aquanet actually, it was made from CFC. So now hairspray actually has more pump containers and things like that. And that's part of the regulation actually that the Montreal Protocol, put in place. So, what you need to remember, okay, is ozone at higher altitudes in the stratosphere is good. Ozone at low layers in the troposphere, like down where we live here, is bad. So, if I ask you, ozone, is it good or is it bad? Your response should be both because it depends on where it is. Okay, so the second most variable gas is going to be carbon dioxide. All right, so we have different ways of carbon dioxide actually naturally and unnaturally coming into our atmosphere, and we have ways that actually is removed from the atmosphere as well. So ways that it can enter is going to be mainly decay of vegetation. So when fall happens and the leaves are falling from the trees, then we're going to see carbon entering the dirt and the ground, and there's going to be more carbon dioxide during that time. Or more carbon. And then volcanic eruptions can also, put carbon dioxide in the atmosphere. Exhalation of animal life. So, we all, hopefully from grade school, when you exhale, you're exhaling carbon dioxide and you're inhaling oxygen. Burning of fossil fuels, and that's going to be one of the unnatural ways or anthropogenic ways that fossil fuels are actually put in the atmosphere, and that's going to be coal burning plants that are, giving us energy to move around and have our lights and things like that. And then also deforestation, because plants actually will take in CO2 and then breathe out or release oxygen. So they're kind of the opposite of what animals do. So if we get rid of plants, then we're getting rid of that natural way that plants will actually consume that CO2. Okay, and removal. Plants use CO2 during photosynthesis and then stores it in its roots, branches, and leaves. So it's just kind of part of what I was going through. So plants will actually, use that CO2. So they're going to actually take it in during photosynthesis, and then it's going to store it in its branches, and then, decay will happen, and that's when you're going to start seeing it actually more release. So CO2 actually does kind of go up and down seasonally, depending on, where the plants are. Areas that don't have seasons, that don't have the jungles, they're going to have more of a consistent CO2 level. But areas where you have these definite 4 seasons, you'll see more of a fluctuation there. And actually, what holds most of our CO2, not all of it, but quite a bit of it, is going to be the oceans. So what happens is the CO2 is going to dissolve. You can see this picture here, all right, and it's going to be in the ocean. It'll kind of sink down to the bottom of the ocean there, and there's going to be a store of CO2. In the ocean there. So there's quite a bit actually in the ocean, more than you would think. It's more than 50%. And then we also have quite a bit of it, from decayed animals, mainly the dinosaurs, because that's where oil comes from, actually down, further down into the dirt, and in our mantle and in the crust actually is where most of the CO2, actually the carbon, is located. So that's kind of like how it comes in and then how it goes out. There's definitely a cycle to this, but just so you guys are aware of all that. Okay, and then what did our early atmosphere look like? It was not the same as it is today. Back during, before dinosaur times, it was most likely hydrogen and helium. Helium has a very high escape velocity, meaning it moves very fast when it's heated. And so a lot of it just kind of like the atoms just moved really fast and eventually got enough of momentum up to just kind of like, I don't know, just go off into outer space. So we kind of lost a lot of the helium that we had in our atmosphere into outer space, throughout time. And I think, okay, and these are some group questions actually that I have in my live classes. I go through these group questions. I would suggest you guys try to answer these. I do pull from these questions when I'm making the tests up, so it's a good, source for you to study. If I were you, I would kind of, pause these videos and maybe see if you can't answer them yourselves when you're in the middle of them. But this is the last one, or the last slide on this video. And next we'll be going over the vertical structure of the atmosphere.